Hello and welcome to a short series of videos on designing programming languages. We're going to use the OHM language library. OHM is a JavaScript library for building parsers, interpreters, compilers, and more, but not only just building them, but also designing them. In addition to a nice set of documents, which you can find online, OHM also comes with an interactive editor where you can begin, say, by writing programs in the language that you are designing and write the grammar to have them match. So it's a kind of a test-driven development with programming language design, which is very fun. So here's our Hello World program in this language we're designing. It's going to be a small programming language, so I will call it small. And let's start writing a grammar. I know in this language, I want my programs to be a series of, let's say, one or more statements, where each statement, for right now, our statements will just be print followed by an expression, followed by a semicolon, and expressions for right now will just be string literals. And string literals will be made up of a, going to start with a quote character, double quote character, but hey, OHM uses double quote characters, so I better escape that. And I'll have a series of 0 more characters. What are characters? Well, OHM actually comes with a built-in rule called any, which is any character whatsoever, but I don't want to have in my strings, I don't actually want to have double quotes inside, right? So I'm going to say excluding double quote characters. So in any character, I'll excluding a double quote. And this actually matches, and you can see that everything is green because things work now. I can also say, for example, oh, you know what? Let's make sure that I'm actually rejecting code with double quotes inside. And what I'll say to OHM is, oh yeah, I don't want that one to pass. I want this to fail. So put a little thumbs down here. And if you actually fail, OHM will be green. I think in this case, I also do not want to have strings that look like this in them. I don't want to have new lines inside. So I'll say, hey, OHM, I don't want that to pass. But OHM is accepting it right now, even with that new line in there. So I'll say here, oh, you know what, OHM, I don't want the new lines either. And now my test passes. All right, so we have here program statements and expressions. We have string literals and we have characters. Notice that the first 3 here begin with a capital letter. This is OHM's way of saying you are allowed to have spaces, as many spaces you want in between all of these entities over here. So we have saying print, expression, and semicolon. I can have, if I wanted to, I can have multiple spaces in here. This is actually a bad example. Let me go to the passing one right here. I want to have lots of spaces here, lots of spaces there. That's actually okay, right? Because if you start with a capital letter, then spaces are allowed here. Whereas with a lowercase, they're not. Let's see that actually a little bit better. Let's instead of having just string literals, let's allow ourselves to do things like print numbers. Like I'll print out the value 20. Now this doesn't pass right now because the only expressions we have are string literals. But let's allow, say, integer literals. Okay, where an integer literal is going to be a sequence of 1 or more digits. And now things pass. Now notice, because intlit is lowercase, it will not allow me to have spaces in between here, right? Spaces say, no, you have a 2 already. This is a sequence of 1 or more digits. This is a lowercase. So spaces here are not allowed. But I can have as many digits as I want, and that's fine. Okay, so we now have a very, very tiny programming language with integers and strings. Why not Booleans? Okay, let's go for true and false. Let's allow true to go in here, and let's allow false to go in here, and see where this takes us over here. Can I write, oops, should have written the test first, right? Print true, print false. Does that pass? That does pass. I'm going to try something that I don't want to pass. Print true, like so, and print false. I don't want these things to pass, right? So let me do a down arrow. I don't want it to pass, and yet it does. When I look at this thing, I see print followed by true, but over here, I actually want there to be a space there. But instead, ohm happily matched print, and then it matched true. So you got to be careful over here. We want to make sure that keywords like print don't run into other words and become what are essentially identifiers. So one way to work on that is to say, you know what, I want to have a, not the string print here. I'm just going to say, I want there to be the special word print, the special keyword print, which is going to be made up of the letters print, but not followed by an alphanumeric character. And now this thing properly fails because print not followed by an alphanumeric character. Well, this final T here was followed by an alphanumeric character, so it did not match the word print. And this is a good thing to be able to do. And while we're doing it for the word print, let's make sure that true and false work the same way. We don't want to run the risk of having true run into a letter or a digit, which is what ALNUM is. True and false. Let's make sure these do not run into anything, right? So ALNUM, so you're seeing here the digit, any, and alnum. I'm using some built-in rules in ohm. If you go to the ohm documentation, which we see here, and you go to the syntax reference, if you look for built-in rules, you'll see that any letter, lower, upper digit, hex digit, ALNUM space, and a lot of nice things here are built in that we can make use of. So let's see, anything else right here at the moment? Sure, let's do comments right now in our programming language. So let's put a comment here, and more commenty goodness right over there. So we'll go / until the end of the line. But these comments right here, we really kind of want to ignore them. We want the comments to, they'll exist, but great, but we want to actually treat them like spaces. Just like we can have spaces in here, comments are basically going to be treated like spaces. So what ohm has a built-in rule called space right here, a single white space character. And what we can do is we can add on to that built-in space character, and we can say, okay, in addition to having white space, anything that starts with the backslash and has a bunch of characters that go until the end of the line. So any character that's not a new line goes to the end. You'll have 0 more of these. If we run this all the way to, and by the way, we're going to call this a comment for reasons we'll see later, then this works. We can just say, hey, as long as you have / and then you have non-new line characters, as many non-new line characters you have, that will be basically a comment and will be ignored. All right, let's do one more thing. I would like to add in here a floating point numbers. So let's go with print of 38.22 times 10 to the negative 9th, maybe 11.8 e plus 8 prints something big, 0.0 times 10 to the 100, something like this. Okay. Now here we have a floating point number. It's, of course, the test is not passing right now. We want to have this fractional part, and then actually optionally an exponent part, right? Because we should be able to have something like a 24.11. This should work too. We don't need an exponent part. So let's leave this test in here and let's get it to work. So we're going to have in here something we're going to call floating point literals. And for our floating point literals, we will call them floatlets, and we'll say I got a sequence of digits. And my digits are followed by a dot with more digits. And then optionally, using a question mark, we'll put in either an E or an E. And optionally here, a plus or minus, plus or a minus, and then one or more digits after. That'll be a floating point literal. And you can see that it's not passing over here. What's not passing? It's found a print, but then it found this 38 to be an integer literal instead of a floating point literal. And that's because Ohm said, okay, I see print. I'm going to look for an expression. Let me see, does what I'm looking at right now, this 38.22, is that a string literal? No. Is it an integer literal? Well, it actually finds the integer literal for 38. And then it thinks it's done with the expression. So it's basically saying, hey, do you got a semicolon there? I'm kind of like done with the expression, or maybe have another digit. So because Ohm tries everything in order, first string literals, then integer literals, then float literals, it's important that we put float literals before integer literals. And now everything turns green. Okay. Let's see, while we're here, I want to do one other thing. I want to add variables here. I want to make it so that we can say things like print X, or as a matter of fact, we'd like to be able to say, hey, let X be an integer, which is originally 1,000, something like 1,000. So I want a new kind of statement. I want variable declarations, and I would like to be able to have identifiers to be used as expressions. Let's leave this failing test in and get to work. So in addition to statements that are, in addition to print statements, I also want to be able to say something like let identifier with a given type be initialized to some expression and end with a semicolon. We have a very interesting error here with the words inconsistent arity. In Ohm, the right-hand sides of any rule must have the same number of components across all of its different choices, right? So print exp semicolon has 3, but let id semicolon type equal sign expression, so it has 7. Whenever this happens in Ohm, you're supposed to tag the alternatives with something descriptive to make Ohm happy, right? So now we have something called statement print, and we have statement var_dec. So this is good. Now we can just go attack the problem that we don't have let. There's no rule let. Let is going to be another one of these keyword things. So let is going to be the word let, not followed by an alphanumeric, because we don't want it to run it. Like if I had the word let's, L-E-T-S, I would want that to be an identifier, certainly not let followed by S, which it would be by default. So we have our let in there. We don't have IDs. All right, so IDs are going to be interesting because an ID is at least one letter, but it could be followed by 0 more letters and digits. By the way, AL_num is letters and digits. So this is how I'm going to specify my identifier. And then I'm going to allow my identifier to be another kind of expression. We're missing type over here. So let's get type in here. Type will be the word, oh boy, int, float, bool, or string. I just realized that we're starting to need a lot of these things. And it's not weird to have a lot of keywords. In fact, it's fine, really. But we do have to type them in. Int, float. This is the part where you advance the video by about 10 seconds. String. And bool. Not ALNUM. Okay. Things are they almost passing? No, everything's still, everything's green. Okay. It greened up, which is nice. So we have our final test passing. We have variable declarations, and we have identifiers as strings, we have floating point numbers, we have integers, we have comments. We are well on our way to making a decent programming language. In the next episode, we're going to add operators. See you soon. Bye.